All right, in this video, we are going to talk about organizing quantitative data. All right, so the first thing when we're talking about organizing quantitative data is that we organize the quantitative data by grouping the observations into classes. Sorry. Those also in some books you'll see them as categories or bins. And then once we group the observations together into classes, then we treat the classes as distinct values of qualitative data. All right. And so then once the quantitative data is grouped into classes, then you can draw frequency distributions just like we did in the previous section. And you can do relative frequency distributions as well. It's exactly the same as what we did for qualitative. All right, so now there are some general guidelines for grouping quantitative data into these classes, and there's three important guidelines. So the number of classes should be small enough to provide an effective summary of, but large enough to display the relevant characteristics of the data. And so a rule of thumb is that the number of classes should be between 5 and 20, right? If you only use one class, well, then every observation gets dumped into that bin, and so it just doesn't. It just looks like if you look at a graph of that data or a chart that we'll talk about, it's just one big block basically, and so it really doesn't tell you anything about the data itself. And if you use too many, then that kind of doesn't really summarize the data. Okay. So number two, each observation must belong to one and only one class. We can't have ambiguity about, does this number belong to this class or the other class? It has to be every observation belongs to one and only one class. All right, and if feasible, all the classes should have exactly the same width as far as the range of numbers. If you took the higher end versus minus the lower end, that should be the same for all classes. Okay. All right. So there's three different methods that we are going to look at for breaking things into classes: single value grouping, limit grouping, and cut point grouping. All right. In single value grouping, all you do is use the distinct values of the observations as the classes themselves, and this one is really nothing different than what we did for our quantitative data. So if we look at this example 260, all right, and so let me see this. Hopefully this will work out all right. Yeah, that looks good. Okay, so if we're going to use single value grouping, what we're going to do is to treat each of these numbers as if it's its own class. All right. So starting off, we have look at these numbers here. We have 1 as a value. Then we have we don't have 2, but we have 3. But I'm going to go ahead and write the 2 there, and then 3. And 4. So we're going to use that as our classes, and then we're going to count those up. All right, so we have 3 3s. Actually, this is small enough to where we could just count these together. So we have 1, 2, 3, 4, 5. So we have 5 3s. So the frequency for 3 would be 5. There's 0 2s. We have 1, 2, 3 4s, and 1, 2 1s. Okay. All right. So here are the classes, and here are their frequencies. I should have wrote that a little lower, but there's kind of a lot of stuff here. All right. And if we want the relative frequencies, then all we need to do is to add these up. So that's going to be 2 plus 5 is 7, plus 3 is 10. Okay. So that is going to make it really easy to calculate the relative frequencies, right? The total is 10. So 2 divided by 10 is 0.2. 0 divided by 10 is 0. 5 divided by 10 is 0.5. And 3 divided by 10 is 0.3. All right, so there's our relative frequency distribution. All right, so you can see that's really nothing at all different than what we did when we were talking about qualitative data. All right, the only issue is that doing this is not great for other types of quantitative data. All right, so I'm going to go ahead and move on to the next example. All right, and that is about limit grouping. In limit grouping, each class is a range of values, okay? So each of the classes has a lower limit, and that is the smallest number that should go in the class in this type of grouping. Each class has an upper limit, which is the largest number that should go into the class, okay? And the class width is the difference between the lower limit of a class and the lower limit of the next higher class. All right, so let's take a look at an example there. All right, it says use limit grouping with a first class of 0 to 9 and a class width of 10. Okay. All right, so let me take a picture of this so I can draw on it. All right, so they tell us that the first class is 0 to 9. So I'm going to write that down. Okay, and so then the next number here would be 10, right? That would go here. All right, and then the class width, right, should be 10, right? So because it's the lower limit of this class minus the lower limit of this class. And so so this would be 19. And then the next class up would be 20. All right, 20 minus 10 is 10. All right, the next number up would be 30. And the next number up would be 40. All right, and that looks like it will cover it, right? The biggest number in here looks like it's 41. So that would cover all of the groups, okay? And then what we would go through and do is to tally all these up, right? So 9, I'd put a mark here, 27 here, 16 it goes in here, 24 is between 20 and 29, 18 is in between 10 and 19, 37 would go here, 20 would go here, 21 would go here, 31 would go here, here, another 31, 41, 9 would go here, 32, and another 32, and then 39 will all go in here, 4, 15, 27, 37, and 30. All right, so we tallied all those out. So then the frequency, right, would be 3, 5, 8, and 1. Okay. All right, next up we would calculate the relative frequency. Of each of those. So the first thing that we would have to do is to add all of these up. So 3 plus 3 is 6, 11, 19, 20, right? So the total is 20. And to get the relative frequencies, what we would do is just divide. So 3 divided by 20 is 0.15. So 3 divided by 20 again, 0.15. 5 divided by 20 is 0.25. 8 divided by 20 is 0.4. And 1 divided by 20 is 0.05. So there is our relative frequency distribution. Okay. All right, so again, just going back over that one. Each class has a lower limit, and that's the smallest number that will go in that class. Each class has an upper limit. That's the largest number that should go in that class. And then the class width is the difference between the lower limits of successive classes, right? So here they told us the first class was 0 to 9. And so that would mean that this would pick up as at 10, right? And then, so that gives us a class width of 10. So all of these are going to be differ by 10. Same thing with the upper limits as well. Okay. All right. And so the next type of grouping is called cut point grouping. And so it's similar to limit grouping in that each class consists of a range of values, all right, and each class has a lower cut point and an upper cut point. So the lower cut point in this type of grouping is the smallest value that should go in the class, okay? And now the difference is here. The upper cut point of a class is the smallest value that should go in the next higher class. So that's where it's different from the previous type of grouping, okay, from limit grouping. All right, and so the class width in this case is the difference between the upper cut point and the lower cut point of the class. All right, let's take a look at how this would go. All right, and we're going to look at problem 2.68. All right, it says use cut point grouping with a first class of 10 to under 15. All right, let me take a picture. All right, so the first class is 10 to under 15. That's a terrible 15. All right, so that means that the class width, the lower cut point's 10, the upper cut point's 15. So that means that the smallest number that will go into the next higher class is 15. All right, and then the class width, right, is 15 minus 10, which is 5. So that means this would be the upper cut point here, right, will be 20, right, because 15 plus 5 is 20. Remember, you want to try and keep the class widths the same on all of these, all right? So the next one would be 20, and then 20 to under 25. And it's a good idea to write the under if you're doing this, because it's easy to mix up this cut point grouping and the limit grouping And the limit grouping, the 25 would actually go into this one, right? So right under 30. The next one would be 32 under 35. And then 35 to under 40. All right, and that should do it, right? There's nothing that's bigger than 40. So 38.8 is about the biggest. So that looks okay. All right, and so now we would start tallying these up. So 12.7 would go here. 20.9 would be in this class. 22 would be in this class. 10.1 would be in this class. 22 would be in this class here. 16.6 would be in this class. 26.2 would be in this class. 38.8 would be in this class. 17.3 in this class. 19.5 in this class. 15.8 in this class. 24.3 in this class. 13.2 in this class. 12.9 in this class. 16.4 in this class. 24.5. 25.2 would be here. 22 would be here. 20.8 here. And 26.9 right here. Okay. Okay, so that would give us the frequencies now. We can write those down. All right, and so we have 4, 5, 7, 3, 0, and 1. All right, so there's our frequencies, and then our relative frequencies. Okay, so we would need to add these up. So 9, 16, 19, 20. All right, and then to get the relative frequencies, we would just divide. 4 divided by 20 is 0.2. 5 divided by 20 is 0.25. 7 divided by 20 comes out to be 0.35. 3 divided by 20 is 0.15. 0 divided by 20 is 0. 1 divided by 20 is 0.05. All right, and there are our relative frequencies when we do that. Okay. Okay, and so that is how you would group these quantitative, data, organize it into these classes. All right, so there's 3 different ways you could do that. All right, so now having done that, how do you know which grouping method to choose? For the single value grouping, that is really only useful when you have discrete data in which there are only a small number of distinct values, right? Those last 2 examples that we did, single value grouping probably wouldn't really work for those. The second example that we did, limit grouping, right, was limit grouping. You would want to use that when the data are expressed as whole numbers and there are too many distinct values to employ single value grouping. Right, so that was like this example here. In this first example, we had only a few, values. There weren't that many different type numbers in there. But in this one, there's a lot of different numbers, right? So, there's probably too many here to use that grouping, the single grouping, like we did before. And then the cut point grouping, use this when the data are continuous, right, and expressed with decimals. So like this example right here, then probably cut point grouping is your best bet on there. All right, so that's which method to use in what circumstance. The other thing is about choosing the number of classes. It can be pretty subjective, and a lot of times it's done with technology these days, and so we're not going to go into a huge amount of detail about that topic. On homework and test questions, right, the grouping method will be chosen for you, and you won't have to make a decision about those. So, it will just they'll be given to you, so you don't have to make that choice. That's really comes with experience and doing this if you're doing it by hand. Okay. All right. So now you have some quantitative data. You group it into classes. And then after you group it into classes, you get that frequency distribution and the relative frequency distribution. And then what you can do is generate a nice picture of those classes with what's called a histogram. So a histogram is just a graphical method of displaying classes of quantitative data. Okay. And those classes are displayed usually on the horizontal axis, right, on the graph, and the frequencies or relative frequencies or percents are on the vertical axis. So it's kind of look like a bar chart, but it's not exactly the same. The frequency or relative frequency or percent, whichever one of those things that you're looking at, is represented by a vertical bar whose height is equal to that frequency, relative frequency, or percent. And in a histogram, the bars should be positioned so that they are touching each other. Okay. So for a single valued grouping, you just label the bars with the value that you have. And for limit grouping or cut point grouping, usually use the lower class to label the bars. So although sometimes the midpoints are used. And whatever, you might use the frequencies. In that case, it's called a frequency histogram. You might use the relative frequencies to represent the height of the bars. So that would be called a relative frequency histogram. Or if you're using percentages, it's called a percent histogram. Okay. So now I am not going to make you generate histograms. I really needed for you to go through this because we're going to be looking at pictures, histograms that look like this. So I kind of need you to know where these are coming from, right? Remember, we organize these things into groups, and then we get a frequency or relative frequency histogram based off those groups, okay? So we're going to be looking at pictures like this, and I just really need for you to understand, what these things represent. All right, so what I'm going to do is just show you how to generate a quick histogram on Desmos. It's really easy. So desmos.com, and click on graphing calculator. To type in your list of numbers, then you would just type it in this format here as a variable, a equals, let's see, there we go, a 10 element list like that. So this is a list, the values are separated by commas, okay? And this, I think this is the exact data that we did earlier, pretty sure, yeah. Okay. All right. Then what you would do is do histogram, and then that variable. So these need to match, and then this is your class, your bin width. Okay. So you just do histogram, and then A, and then it will automatically choose a bin width of 1 for you. right? Which is what we need for this single value grouping like that. Okay. All right. So you can see. Go look back at our. Oops, that's the wrong one. This was our frequency distribution, right, that we generated. So 1, right, we had a value of 2, and so you can see that's how high the bar is. For 2, there was no bar, right? For 3, the bar was 5, so right here. And 4, the bar was 3 right here. So you can see this generates a really nice histogram for you really easily. You just put the data in, it does the grouping for you and whatnot. You can change the bin widths if you want, like this. You can see this is what I was talking about earlier. If I use only one bin, which is what I did here, well then what you get is just one big bar, which basically doesn't really tell you a whole lot about the graph. Okay, so this is a really nice way of doing it. If you zoom out, like say you mess with the graph right here, you zoom in too much, if you hit this little plus right here, it'll zoom you back out to where you can see it. So sometimes you might do this command, and like if you're off the screen, you might say, hey, well, it didn't do anything when I typed this in. So you can hit this plus and it will zoom to where it's at. So this is count. They call the frequency count on Desmos. And you can do the relative one. So when I do the relative one, you can see the bars are a little bit shorter. So if you want to get a better picture, you can hit that plus and it will zoom it out. So this is a relative frequency histogram, right? And so you can see the bar for 1 is 0.2, the bar for 2 is 0, the bar for 3 is 0.5. Right, so you can see it right there, and the bar for 4 is 3. Okay, so those are the types that we talked about. All right, and so say if we had one of these other ones here, like if we type this in, it should do exactly the same thing. It will generate us a. Let's see if we can do that really quickly. So if I type this in, 9, 27, 16, 24, 18, 37, 20, 21, 31, 31, 41, 9, 32, 32, 39, 4, 15, 27, 37, and 30. So that should be 20 elements. Okay, if I if I don't specify the bin width inside here, it's automatically bin width 1. So you can see that's the kind of picture I get. When we did our data, though, we used a bin width of 10, right? Because for this limit grouping, it was 10 minus 0. So if I do this, then we should get exactly, I'll switch back to count for the first one and hit that zoom button. All right, and put this 10 in here, we should get exactly the one we want. So it's a little bit harder to see. Our the way we have our classes 0 to 9. So we were grouping on the left one right here. So if you hit left, it should look exactly the same as ours. Let me zoom fit it again. Keep having to do that. All right, and so that should be about exactly how we want it. So this class was 0 to 9. You can see the frequency was 3. 10 to 19 right here, frequency was 3. 28 to 29, frequency was 5. 30 to 39, the frequency was 8. 40 to 49, the frequency was 1. So you get this nice picture right here relatively easily. If you want the relative one, you can do that. Zoom it out. And so you can get a pretty good picture of what the data looks like. All right. So as the course moves along, we probably will not be, drawing these histograms out much, but we will sure be looking at these histograms as we go through the course. So I really need for you to understand, what this picture is representing. This is some quantitative data that has been grouped into these classes, right? And then either drawn a frequency histogram or a relative frequency histogram, right? And you can tell the classes by looking down here. And then you can tell by the height of the bars will tell you either the relative frequency or the frequency or percent if it's drawn that way. Okay. All right. So on this section, there is no quiz. Actually, there's one more video to go after this, but there's no quiz on this or homework problems for fall 2020. So, so that's it for this video, and the next one is very short. So. And that will be it for this section.